Welcome back, everybody. We are in Module 4, and when I start the software up here, this is screen recording software, I'm looking to see is my microphone catching my voice, and you can see that right there. And I'm also looking down here to make sure I have the red dot, and then also to make sure that this is going up like 1920, and all those signs right there tell me I'm recording, which is a good thing. So we've been talking about computers because you're in a computer class, and and we've been talking about hardware. And here, what you're looking at on the screen, what we're going to learn about this week in Module 4 is we're going to learn about software. And so we're just going to think about how do we think about software and what are the different categories of software. And so part of moving into any domain of knowledge is learning like how do we organize the different pieces of information in that domain of knowledge? What's the ontological structure? And so you're seeing an ontological structure here. And when we learned about metaphysics and ontology last week, we learned that metaphysics is the branch of philosophy that deals with fundamental first principles of things, including abstract concepts such as being, knowing, substance, cause, identity, time, and space. And I like sharing this because I think it's super fascinating to think about first principles. And a first principle is like, it's irreducible. It's like this is the source, the essence. You can't go any further than that. Like, how is it that I'm actually thinking? And that's metaphysics. We're talking about metaphysics here when I'm thinking about like being and knowing. Like, how do I know stuff? How am I actually thinking? What is it that is actually animating me and making me alive? And it makes everybody else alive. In some ways, that's a fait accompli. And a fait accompli is something that we just take for granted, a thing that has already happened or been decided before those affected hear about it, leaving them with no option but to accept it. And it's also something that most people don't even think about. Like what animates me? What animates the trees? What animates, my dogs or other animals? What animates all of us? Is it some force? Like what makes us alive? In some ways that's a fait accompli. And how do we know things? How do we think about things, right? So these are metaphysics. This is metaphysics. It's thinking about fundamental first principles of things, including being, knowing, substance, cause, identity, time, and space. So we learned that last week, and I think it's fun to talk about and think about and to expand our perspectives just on being here as humans. And this is definitely related to computers because in computers, part of computers, if we look at a Venn diagram, and so here's a Venn diagram. And a Venn diagram is like concepts that overlap. We could have concept Y, we could have concept X, we could have domain of knowledge Z, and these different domains of knowledge might overlap. And so here's where X and Y overlap. It's the intersection of X and Y. Here's where Y and Z overlap. It's the intersection of Y and Z. And here is where X, Y, and Z all overlap. It's the intersection of all three of them. And so if these were domains of knowledge, this might be the domain of knowledge of computers right here. And this might be the domain of knowledge of philosophy. And this might be the domain of knowledge of psychology. And you could have other domains of knowledge here like sociology. But when you create software, which we're going to talk about this week, one of the things in this module, one of the things you really want to do when creating software is to create software that people are going to use. And to create software, you have to understand computers, domain X, but you also need to understand psychology, domain Z, and you also have to understand philosophy, domain Y, because when you think about all that and you get to this area right here, you're going to be able to create software X for people, Z, right? Z, people, psychology, and you'll have a philosophical perspective on why you're doing it. And that's domain Y. And if you do all three of those, you're going to be more likely to create software that is successful. So that is like, why it's important to kind of think about fait accompli and not just be, like here is the rote routine sort of, just definitions of things, but to actually kind of think about things from a larger perspective. Because when you do that, it allows you to make better decisions and be more effective in life. And so I like to share those bigger perspectives from other domains and bring a multidisciplinarian approach to talking about software. And there's a great video on Netflix. So if you go to YouTube And I think I've mentioned this in one of the lectures already, but if you go to like Netflix Social Dilemma trailer, there's a movie here about people who create software, The Social Dilemma, and it's very philosophical, and it very much is about like psychology and how do we create software that's addictive for people. And the executives talk about how they intentionally tried to create software that's addictive for people. And some of these executives are like, I will not let my kids use the software I created. Right? And so this is a great video just to learn about software and the creation of software. And again, I know this is all a little bit high level and philosophical, but what we're learning about here this week in this module is software. And so this is a great video to check out. And one more video, which is really cool to check out, is the Pirates of the Silicon Valley, the Pirates of the Silicon Valley. And that's an old movie, but it's about the creation of Microsoft and Apple. And so here's the trailer. But people who have created software, like in the computer industry, they're very philosophical people. And you could see that in this movie here. Particularly Steve Jobs is a very philosophical person, and he studied different cultures around the world and different belief systems and brought in a lot of sort of Zen and Taoism and Buddhism into the creation of software and computers. But that's just part and parcel for the software field. It's people who think deeply about humanity and how does humanity function and how could we create software to help humanity function more effectively. And so that's the first thing I just want to say about all this is we're starting at a philosophical area, and we're starting with metaphysics. And we got to metaphysics because we started looking at an ontological structure. This is an ontological structure. And if you look at the definition of ontology, one of my favorite words, ontology is the branch of metaphysics that deals with the nature of being. But also ontology is a set of concepts and categories in a subject area or domain that shows their properties and the relations between them. So it's basically concepts in a domain, and how are those concepts related? So here are concepts in the domain of computers, and this is how these concepts are related. And I'll explain these in a second. And then here's another ontological structure, and these are concepts in a domain or multiple domains, right? And this is how those multiple domains are related, where they overlap. So when you hear the word ontology, and this is a really powerful word to know, you could say, well, what's the ontological structure in this domain? And you could sound really smart, or that's a little bit pretentious, but you have a framework for starting to break down larger domains of knowledge, break them down into chunks, and show how those different chunks are related. And so that's what you do when you create an ontological structure. But also ontology has two definitions, and their definitions is that it's the branch of metaphysics that deals with the nature of being. And the metaphysics is fundamental first principles. It's the branch of philosophy that deals with fundamental first principles like being, knowing, substance, cause, identity, time, and space. It's really super fascinating stuff. I'm a philosophical guy, and I love the fact that computers in the computer industry are really rooted in philosophy and multidisciplinary approaches to creating amazing software which transforms humanity. So all of that, we're going to start out here learning about software. So maybe like a good slide to start with this entire presentation would just be to have this up here at the top and just put software. That's what we're learning about here. And so to learn about software, it's good to start here and think about how do we break up the knowledge in relation to computers. And so computers can be broken up into two categories. There's hardware and there's software. And we've been learning about hardware, but you need both of these categories for a computer to work. So the software runs on the hardware, and hardware without software is useless. And so you need both categories. And we've learned a lot about hardware over the last couple of weeks, and last 2 weeks specifically. And now today, we're going to learn about software. And though we started out at a pretty high level with philosophy, software is a really easy concept to grok. And the first thing to sort of grok, you already know what it is, but the first thing to grok is that computers can be broken down generally into two big categories. One is hardware, and then the other is software. And so here's a question for you. We talked about ways in which we could break hardware down, into additional categories, right? So think about that for a second. Pause the video and ask yourself what additional categories could hardware be broken down into. We already talked about this. See if you could come up with that answer. And I'm going to create those categories here on the slide and pause the video to do it. So hold on. All right, did you come up with the answer? So here's the additional categories that hardware can be broken down into. So computers can be broken down into hardware and software. And we can break hardware down into input, processing, output, and storage. So we can say there's input devices like this mouse, or like this camera, or the microphone, or this keyboard. These are all input devices. Or they're output devices like your speakers, or your monitor, or a printer. Or there's storage devices like memory, ROM, cache, registers, secondary storage, solid state like solid state drives or flash drives or SD cards. There's magnetic storage like hard disk drives. There's optical storage like CDs or DVDs, right? So we could further create structures beneath storage here. We could put primary storage, secondary storage, and under secondary storage we could put solid state, magnetic, optical, and then under each of those we could start listing out. And so here we're really creating this ontological structure, this tree-like structure, where we're breaking the different pieces of knowledge into categories and showing how they're all related in this domain of computers. And so we could break, the first thing for you to know about software is that computers can be broken up into hardware and software. You need both of these for a computer to work. But then we could further break up software. So we could break software up. So we went from computers to software. And we could further break software up into system software and application software. And then we could further break up system software into your operating system, your utilities, and your drivers. And then here we could break up application software into some of these categories. These categories here are just sort of arbitrary, but that's how you could break them up. So if we did all of that together, it might be kind of interesting to build this together. So I'm just going to do a Control-C, copy, Control-C on my keyboard, Control-V, paste, and paste that in. And I could select all of these things by holding down Shift and then just selecting each of these individual things. And I could change the size of this. So I'm just going to change the size of that. But I missed one, so I'm going to do Control-Z and select that one now and see if that allows me to change the size of those. And then I'm going to drag all these up here to the top. And then I'm going to select all these, and I could just select them all like that and drag them all up to the top. And I'll put these all over here. And then under software, we need to add some stuff. So I'll select all these. And software can be broken up into application software and system software. So I really just need those two right there. So I'm going to copy those and put them here. But it gave me all of them. That's all right. And now I'll just delete this one. Delete that. Got to click here. Delete it. Yeah, and I'm showing you here how to use presentations. Oh, that went too far. I'm showing you here how to use presentation software. And so presentation software is like here we're using Google Sheets, right? And so that looks pretty good there. And I could change the name of this one to system software. So this would be system software. And then this one would be applications. Applications. And I'll just leave it apps, okay? So that's applications. And then system software can be broken up into, and we could take all these categories here and copy them again and then bring it down. And we could break all of this up here. And I kind of need to move all of this over, and then I'll have to stretch things out so I have some room here. And that's a little bit too far. There we go. And now I'll take this line here and grab that dot and move it over here. And I'll take this line here and grab that dot and move it over here. I'll take this line here and grab that dot and move it over here. And I'll take this line here and grab that dot and move it over here also. And so system software can be broken up into these categories right here: your operating system, your utilities, and your drivers, which means I don't need this one, and I don't need this one. So your system software is made up of your operating system, and we'll make that your OS. And we'll also make this one your drivers. I guess we'll do utilities first, utilities. And then we'll make this one your drivers. And I'm just going to click back over here to make sure that this is recording. We're at 14:35. We're doing good. And so that's how system software is broken up. And then application software can be broken up into all kinds of categories. So here, software is broken up into system software and application software. And I like this one better. Here, software is broken up into system software and application software. So we no longer need that slide. And here we have operating systems, utilities, and drivers. Your operating system, your utilities, and your drivers, and that should be OS. Let's make it capital. It's kind of small. Let's make it bigger. And we'll go there for 12. And what is that one? That one's 12. So now they're the same size. And so we've got that on the previous slide. And then application software can be broken up arbitrarily into these categories. There's commercial software, shareware, freeware, open source, public domain. Those are different categories of software, but it could also be broken up into all other kinds of categories. So we could talk about personal productivity. We could talk about social software. We could talk about business software. We could talk about multimedia software. We're going to see some of that here. But this is like a good ontological structure to show you how different areas of computers are broken up into different categories. And yeah, so that's the first part. That's the first part, or the second part. The first part was kind of philosophical. So I'm going to grab all that and just move it down a little bit to center it. So just drag my mouse over all that. Wait till I get that four-way arrow, and then I can kind of bring that into the center. And it's a little bit off center there, so I'll just do it like this. There we go. That's pretty good. Love it. So next thing to know about software is that we have hardware, and you can think about it in a tiered kind of structure. This is like layers of a cake, where this is the bottom layer, the middle layer, and the top layer. And this is how those layers work. And so there's a separation of concerns, and that's the phrase. That's a very unique phrase to, it's a phrase that is used in computers, and it's a separation of concerns. And so here is another way you could see how different areas are broken up, but it really kind of also shows you how stuff works in a computer and what areas are concerned with what. And so you have the hardware area. That's the area concerned with all the hardware. You have the operating system. This is the software that makes your system operate. That's why it's called operating system. It makes your system, makes your hardware operate. It knows how to operate with the hardware. And then we have the application software, which runs on top of the operating system. So you got your hardware, you have your operating system on top of your hardware, and you have your application software on top of your operating system. And so what this diagram tells you is that an operating system is written and designed for specific hardware. So at the hardware level, like in the CPU, that hardware is created in a certain way, and it has certain instructions about how to use that hardware. It's called the instruction set in a CPU. And there's different manufacturers of CPUs and different industry standards about those CPUs. And so, there's a couple of two main general types of CPUs that the computer industry makes operating systems for. And so one type of hardware is hardware that's designed to run Windows, right? And that hardware has its own way of working and its own instruction sets. Another type of hardware that's out there is hardware that's designed to run Mac OS. And that hardware has its own instruction sets. And so hardware that's created to run Mac OS, hardware that's created to run Mac OS can only run Mac OS. And hardware that's created to run Windows can only run Windows software. As a generalization, you could take both of those pieces of hardware and you could put a different type of operating system on them. You could put on like Linux-based operating system. And so that's an open source operating system, and you can install that on your hardware. But the point being here is that to create an operating system, you have to create that operating system for specific hardware, And that operating system, the people who create it know how that hardware works. They understand the instruction set of the CPU of that hardware and other things about that hardware, and they create the operating system to make that hardware operate as a computer. That's why it's called the operating system. But you can't take, generally speaking, there's some exceptions to this, but you can't take like, a Mac computer and install Windows on it. At least traditionally you couldn't. There's more exceptions to that today, and it might be that, well, let's ask ChatGPT, because I'm hitting a place where I'm not totally clear. Can I install Windows on a Mac computer with an M2 chip? Yes. All right. So now it looks like those are aligned. So you could do that. But there might be ways in there which you have a layer of abstraction between your MacBook and that hardware and Windows where there's translation occurring between those, so it'd not be another piece of software between that piece. But this is the general principle, okay? This is the general principle. The operating system has to be created for specific software, and the operating system the operating system has to be created for specific hardware, and the operating system interacts with that hardware. And then the application software has to be created for specific operating systems. So if we came back over here and said, I am running Mac OS on a Mac, but want to install software created for Windows, can I do that? Windows on my Mac, on my Mac, can I do that? And I'm actually not sure what that is. So it looks like you'll need some software again to serve as virtualization or translation, but you can't just natively put Windows software onto your Mac. So it's always changing, and that's why it's good to sometimes go check it out. So the operating system is created for specific hardware, and then the application software is created for a specific operating system. And you could refer to that as just an app. But the interesting thing about this, the separation of concerns, is that an operating system knows how to make the hardware operate. Okay? An operating system knows how to make the hardware operate. And so the operating system knows how to print to every printer that's out there in the world, generally speaking. Maybe there's some small exceptions for really unique printers. But if you have the driver, so the driver, we learned about drivers right here. It's that's one of the categories. If you have the driver for that specific hardware, you install that driver in your operating system, and then allows your operating system to drive that printer, that piece of hardware. That's what a driver does. It allows your operating system to drive a specific piece of hardware, like some unique printer. And so the operating system knows how to print to every printer that's out there. So the application software, people who create application software, they don't have to figure out how to get their stuff to print on every printer in the world. All they have to do is pass a print job to the operating system, and then the operating system knows how to print that on the hardware. So the operating system interacts with the hardware, and the application software interacts with the operating system. And the operating system, they interact back and forth, and these interact back and forth. And so that separation of concerns allows people who create operating systems to focus on just how do I make this hardware operate, and allows people who create application software to just focus upon how do I make on their application software, and they don't have to worry about how to make certain hardware run, like how to print all the printers out there in the world. And so that's a really useful separation of concerns, and that's how you could think about it. But coming back here, just to review, computers are broken up into hardware and software, and then hardware can be broken up into that, and then software can be broken up into system software and application software, and system software can be broken up into your operating system. So we just learned about that, and your operating system would be like Windows or Mac or Android or iOS, right? That'd be an operating system on mobile phones. And then and you also have drivers. And so a driver, if I wanted to, there's a printer right behind me here, and if I wanted to use that printer on this computer, my computer would go to the internet, get a little piece of software called a driver, it would install it, the operating system would, and then my computer would now know, the operating system would now know after it installed that driver, it'd know how to drive that printer, how to drive it, how to make it work, right? How to get it to do stuff. So you install that piece of software called a driver, and it happens usually in the background automatically. And then your operating system knows how to drive specific pieces of hardware. All right, so that's operating systems, that's drivers. And then the final category here is utilities. And so we could come here to ChatGPT and say, can you please explain utilities for me in computers? There we go. Let's see what it says about that. In computing, utilities refer to software program designed to help manage, maintain, and control computer resources. Disk cleanup, disk refragmentation, system monitoring, file compression, file backup, file management. Like these are all, utility software. And so I think of utilities in computers kind of like utilities in your house. And utilities in your house help your house run: power, electricity, air conditioning. Well, that's not a utility, but power, electricity, water, like sewage, trash pickup. That, all these things help your house run effectively. Those are utilities for your house. And here, utilities for your computer help your computer run effectively. So we've learned about those three categories now. The next thing we're going to talk about is just like what is software. And in class, I like to have a little discussion. What's your favorite software? So you might pause the video and reflect upon that, just making sure I'm recording. But there's also, and now that you're done reflecting upon your favorite software, there's also different categories of software. So word processing is for, like writing documents. And if you go to Google Drive, so here I am in Google Drive, I could go up to New, and I could say Google Docs, and I could create a new word processing document and type stuff up. I could write a novel, and I could edit it and spell check it and all that stuff and format it right here in Google Docs. Spreadsheets, so here's Google Sheets. So word processing, like this software here, word processing software, allows you to work with words. Spreadsheets allow you to work with numbers. Word processing, words, spreadsheets, numbers. And again, in Google Drive, you could go to New and you could go to Google Sheets, and that'll launch spreadsheet software where you can work with numbers. And we have entire classes on that where you can learn to do stuff like this and do calculations and formulas and functions. And that's spreadsheet software. So we have word processing software, spreadsheet software. We have databases for storing data, right? And databases are how everything in the world pretty much runs. So if you go to social media sites, TikTok, Instagram, Facebook, whatever, YouTube, like all that data, all those videos, all your posts, all of other people's posts are all stored in software called a database. And a database can really efficiently organize a ton of data. It's a base for data. So that's what a database is. We have presentation software like I'm using right here, where you could convey ideas and create presentations and share that with people. You have application suites, which is a bunch of software bundled together. So you could consider this an application suite right here. We have file storage, we have word processing, we have spreadsheets, we have presentation, there's videos, there's forms that we could create. And so you could consider this a suite of software. There are browsers, which I'm using here on the web, and a browser allows you to browse the web. So I could go to like Indonesia, surf, vacations, and I could go look at different Indonesian surf vacation resorts, which for the sake of time we're not going to do. There's graphics software. So Adobe Photoshop for editing photos. It's amazing what you can do. You might go to YouTube and you could say Photoshop, and you could say Photoshop content aware fill, and you can watch a video about that, and it will like remove stuff, and like it's all gone, and it just fills it in like it was never there. So you can see on the left there was a before, the coffee shop, and they removed that, the coffee mug, and they removed that, and then they just have the table, right? The coffee mug, like it was never there. And you can remove stuff and you could add stuff, and that's graphic software. So you can never trust images anymore because it could all be created. There's video editing software, and you could edit videos, right? YouTube, amazing. There's screen recording software like I'm using right here. There's web-based software, so it's also known as software as a service, SaaS. And web-based software would be like, here in Google Drive, right? I'm on Google. This could be thought of as the cloud, but this is all web-based software. There's also software you can install in your computer. So it'd be computer-based software, right? So you can install it on your computer, like OBS here is not running on the web. I downloaded it and installed it right here on my computer. So that's computer-based software. There's computer-based training. And so you do training on your computer. It's kind of an old phrase. I think I'm going to get rid of that one. So where we've been with software, it's all about making humans more efficient. And where we're going with software is how do we continue to make them more efficient? How do we make humans more efficient? And how do we save them from having to do, laborious kind of tasks and make things more efficient? So this is really software innovation. Think about where we've been all the way back through all of our evolution. What have we been trying to do? And think about how do we build software to make that happen? And, connectivity, personalization, right? Like, those things are all part of like where we're going. It's just making things more efficient. AI, incredible. When you install software on your computer, you'll sometimes hear this phrase, minimum system requirement. So if you look to see, software will tell you how powerful your computer needs to be to run software, how much RAM you need, what kind of a processor you need, the minimum RAM, how much storage you need on your drive, your solid state drive. And those would be known as the minimum system requirements to actually install software on your computer. When you use software, there's something known as an end user license agreement, or ULA. And this is the things where when you sign up, you sometimes click accept, you agree to the terms of service, and nobody really pays attention to them. But that's the end user license agreement with software. And then there's something known as piracy and intellectual property. So I think these phrases should actually be switched. So I'm just going to open that up. I'm going to grab this one and put it up here. And so people create software, and they own that software, and then they sell it to make money. And that's known as intellectual property, that you could own something which is of an intellectual nature. And so this is real property. This is real property, okay? These things are all real property. I had this today. This is real property. It's real. It's real. I could touch it. I could feel it. But this is not real. I got the fortunes of heaven and diamonds and gold. I got all the riches, baby, that the bank could hold. I got houses across the country running end to end, and everybody wants to be my friend. So that's not real property. That's intellectual property, but it's property. And that's a Bruce Springsteen song. And Bruce Springsteen was a really popular singer in the 80s. In case you're not aware of him, you might go right to YouTube and just like a little cultural edification here. Bruce Springsteen. And Bruce Springsteen, what's that song? What's that song? Lyrics, Springsteen, mansions across the country. Everybody wants to be my friend. And that song is Ain't Got You. Ain't Got You, man. It's a great song. I'm going to have to listen to it after I get finished recording here. But super fun song. And he's a really talented musician. And he's got a lot of really great songs. So he's definitely worth checking out. But everything he created, you can't hold a song, right? I could hold real property. I could hold real property. Here, I'm holding this. It's real. I can't hold a song. Right? It's an idea. It's thoughts. It's a rhythm and a tempo. It's pitch. It's the words, the ideas that are strung together. And while I could put a song onto my phone, or while I might be able to burn it to put it onto a flash drive, or put a song onto a CD, and I could hold those things, what really has value can't be held. It's intellectual, but it's still property. And so in our country, we protect intellectual property, and we do that to motivate and incentivize people to create things of an intellectual nature and to be able to monetize them, right? So you could create software, which is intellectual property. You could create songs, which is intellectual property. You could create a movie, which is intellectual property, and you own that, and you could profit from it. And you could create like new drugs and new pharmaceuticals, and you could own that and profit from it, and that motivates people and incentivizes them to invest in creating intellectual property, because then they can make that their work. And if we didn't protect intellectual property, then somebody could create a song, or they could create software, and then anybody else could go out there and start selling that software if we didn't protect it. But because we protect intellectual property in our country, and most countries in the world do, some nations which haven't, I don't know what the phrase is anymore. You're not really supposed to say lesser developed countries or third world countries, second world countries. I think those are out of vogue. What is it? Developing. Thank you. That's the phrase. Developing countries. So developing countries who are still struggling somewhat economically will not enforce protection on intellectual property, because then it gives their people in the country the tools that they need. And so anybody might be able to go get a copy of software somewhere at a store, and it's bootleg software. It's been pirated. But they could get it for free or really cheap and start doing stuff with Photoshop or Adobe Premiere or whatever. And so that would be piracy, right? Some countries not enforcing intellectual property. Or you could go to some websites and you could download movies for free and songs for free, and that's piracy, where you're stealing intellectual property. And so that's why we protect intellectual property in our country, to provide people with an incentive to create things of an intellectual nature. It's called intellectual property. This would be called real property. That's why we call real estate real estate. It's real. It's real property. So that's software. And if we go to our textbook and see our textbook talks about it, you're going to see all of that stuff that we just went through. Compare application and system software, right? We did that. We saw that ontological structure where we looked at application software, and we saw that here computers are broken up into hardware and software is broken up into application software and system software. So application software and system software. And then we looked at the different types of application software: word processing, spreadsheet, databases, graphic software. Explain different options for purchasing software. You could download it and install it on your computer. You could buy it online, and you could also just go use stuff as software as a service up in the cloud. There's, at Google Drive or at other places, you just use software online. It's a website and you pay a subscription fee. So some of the ways you buy it could be a one-time purchase, or it could be an ongoing subscription fee. How do you install and uninstall software? So uninstalling software is like a good thing to know about. And in Windows, you could go to remove, and you could go down to your start area down here, and you could type in remove and go to add remove programs. And then in here, you can look through all the programs installed on your computer, and you could say, I'm never going to use Paint, right? And I could just uninstall that. I don't know, maybe I would use Paint. Most of the stuff you could just leave, but it is kind of good just to go through it and take a look at it, because there's a lot of stuff in here I don't need. But also your system's running. There is a little bit of a hesitation for me just to randomly go and start uninstalling stuff. This is a new computer. I kind of want to just let it burn in and work. But I'm never going to use Microsoft's Mail and Calendar. So what the heck? Here we go. No, I'm not going to do it right now. But I just choose, I just closed that entire thing. I would just choose to uninstall that software. Explain considerations around the decision to upgrade your software. Like if your software's not working or it's not doing what you want it to do, upgrade it. Or go get software that does what you want it to do. Explain how software licenses function. I don't know, there's an end user license agreement. If you want to use a software, you have to click accept, and you can't really negotiate it. So it's not, it's just like on their terms. Categorize the types of application software used to enhance productivity. Describe their uses and features. So word processing, spreadsheets, we looked at all that. Summarize the types of software that small and large businesses use, whatever, right? The different types of software. Describe uses and features of multimedia. That's video editing, that's sound, that's pictures like Photoshop. Describe the features of audio software. So, audio software allows you to edit songs and audio, and you can do that in Adobe Premiere, and Adobe also has some other audio editing software. Features of app creation software, so there's software to help you create software, and programming, so there's software out there to do that. And categorize educational and reference software and explain their features. Like we use Canvas as a content management. No, we use Canvas as a learning management system, as learning management software at our college. And so Canvas is not installed on the computer, it's web-based, and that's an example of software as a service. So if you go through these slides, you can just pause the video and read that, and pause and read that, and pause and read that, and pause and read that, and then backups. So this is important, so I highlighted it. So to recover from a computer crash, you want to back everything up, right? And we already saw how to uninstall software, but to back everything up, like I do all of my files that I need here in the cloud. I just do it at Google Drive, and if this computer here dies, gets destroyed, is stolen, then I just get a new computer and log back in, and I have access to all my stuff. And so that's thinking about, what happens if my computer is completely destroyed and everything is accessible for me. It's backed up, and I'm up and running again just by logging back in from another computer. So, all this stuff is like either not important, or we talked about it. We looked at word processing, we looked at spreadsheets, we looked at presentation, databases. There's note-taking software. If you're a student, you can get software to help you take notes. And there are the three options, or three of the options that are out there. There's software to help you manage your contacts and your email and your messaging. There's project and collaborative software like Zoom or Microsoft Teams or Slack. There's personal, this is super important. So financial management software, personal financial management, highly recommend it. go to City College and take personal financial management, also take investing from the business division and in business, and those will greatly serve you in life. It'll greatly serve you in life to do that. So, and then you want personal financial management software so that you can connect all your financial accounts, your credit cards, your bank accounts, and then once or twice a week, download all the financial transactions that are occurring in your life. Know exactly how much is in every account you're using. Know how much you spent on your credit card, and if any of those expenditures don't belong, so you could contact your credit card company and challenge them. Also be able to categorize what you spend. So if you have a business, you could write off business expenses and keep track of them through the year. So taking a QuickBooks course would also be really beneficial. Highly recommend it. Super important life skill. QuickBooks. And just so you can get your eyes on that, here's what QuickBooks looks like. There's QuickBooks right there, okay? And we offer a course on that at City College. Super important to have personal financial software. There's accounting software. QuickBooks is also used for businesses and accounting. There's computer-aided design, where you could design, everything that's built in the world first is modeled in CAD software, computer-aided design software. And if you look at CAD software, right, you'll start to see images of things being designed. So here's a gear being built. Here's maybe a drill being built. Here's a pulley being built. Here's a tennis ball being built, right? And so people will model stuff in CAD software, know exactly what needs to be built and what little parts need to be built and how they're all going to go together. And then they could send that to production and build all the little parts and assemble them. But everything is built first in CAD software because it's more efficient and less expensive. There's multimedia software, video, images, audio, and more about multimedia software. The audio editing, when you get audio files, you could have an MP3 or these other ones. Those are compressed, and then you could have a WAV or that one, and those are uncompressed, meaning some data has been, the file is going to be smaller, and the quality might be not quite as high as this, but it's going to be plenty good enough. And then we have app creation software, I've seen Unity, and that could help you create video games. And then there's course management software, and these other ones we use here at our college. So that's software. That's this module. I hope you enjoyed that. I know I was just click, 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 going through stuff. So if I was a little bit quick, you could go back and slow things down. You could watch a little bit of it, listen to it, let it sink in, go get a drink, like a glass of water, or do some push-ups, come back, watch some more. But there's some really good content in here. I really love the philosophical stuff. High-level takeaways is personal financial management software, QuickBooks. Definitely take that class. Take personal financial management class. Take investing class here at City College. Those will certainly serve you well. And then also just ontological structures is the other high-level takeaway here. And then also this structure here where there's a separation of concerns. And then just making sure you're really fluent with word processing software and spreadsheet software. That's also going to really help you in life, making sure you know how to use word processing and spreadsheets. Spreadsheets are super important. Take a spreadsheet course. So spreadsheets, QuickBooks, personal finance, and then also investing. Take those 4 courses. They're going to serve you well in life. Take them just because it's good to know them, and they're also fun. But make sure you get a good teacher. So talk to academic counselor, and he. And I currently really like Lori Swain, so you could go Lori Swain. She's my favorite, also just because, we work, our offices are close to each other, but I know she does an amazing job. This isn't to say that other people out there don't also do an amazing job, but she is 100% amazing. So if you don't have an academic counselor, send her an email and say, hey, my teacher Todd said that I should have an appointment with you just so you can look everything over and make sure, help me figure out what's the best goal to achieve, how do I transfer, get a better job, whatever. She'll help you figure that out. And which classes do I need to take to get there? So you don't take classes you don't need, and that saves you money, saves you time, and also she'll help you find the classes with the best teachers. So definitely send her an email if you haven't met with an academic counselor within the last 2 semesters. And then she'll be your academic counselor. She'll be your friend. You could always stop by her office and say hi and get, she usually has little pieces of candy, so she's a good person to know. All right. Hope you have a great day. Catch you next time.